When considering the difference of two means, there are two common cases. Either the two samples are paired, or they are independent, or unpaired. When applying the normal model to the point estimate, corresponding to unpaired data, it is important to verify the conditions before applying the inference framework using a normal model. So first, each sample mean must meet the conditions for normality, that is, independent observations and not too much skew for the sample size. And that second condition can be relaxed as the sample size increases. The second thing we need to check is that the samples need to be collected independently. That is, they cannot be paired up. When these conditions are satisfied, the general tools of inference may be applied. So from start to finish, first again, we verify each data from, we have data from two samples that are independent from each other. So verify you have unpaired data. State the hypotheses using mu1 minus mu2, or difference of means. Essentially, the difference of means is equal to 0 or not equal to 0. Check the independence or normality conditions for each sample. So you have two different groups. Check the conditions for each group. Calculate the point estimate of standard error. The point estimate is the difference of the two sample means. Standard error is the square root of the first sample standard deviation squared over that sample size, plus the second standard deviation squared over that sample size. From there, test statistic, point estimate minus null value over standard error, which in this case is x1 bar minus x2 bar. The minus 0 you can keep or take away. It doesn't add anything. But then divide by the standard error. From there, calculate the two-tailed p-value, where we use the degrees of freedom as the smaller of the two sample sizes minus 1. Using the tcdf command, the p-value is the tcdf of the absolute value of the test statistic. That is, if the test statistic is negative, drop the negative sign. To 999 degrees of freedom times 2. After that, once we have our p-value, we'll compare it to the significance level, which is usually 0.05, and we'll make a conclusion. If the p-value is less than the significance level, then that would be considered evidence to reject the null hypothesis. If the p-value is greater than or equal to the significance level, then this would be considered insufficient evidence to reject the null hypothesis. All right, one last example. So use the sample data given here to compute the p-value for the difference of means. And for this case, I'll just assume the conditions have been met. So first off, we have our hypotheses written. My point estimate would be the difference of the two groups. So the 42 and the 45. 42 minus 45. Okay. So the point estimate is 42 minus 45, or negative 3. If you want to reverse that order, I'm matching the order that's in my hypotheses. If you want to do B minus A, get positive 3, that's fine. It's not going to change our answer at all. The standard error, square root, so again, square root of the first standard deviation, so this 12 here, squared over 49, plus 14 squared over 36. So 12 squared over 49 plus 14 squared over 36. So I get a standard error of 2.895, so about 2.90. Degrees of freedom, the smaller sample size is 36, so we'll go with 35 degrees of freedom. Test statistic is the point estimate, so negative 3 minus 0 divided by the standard error, 2.90. And I get a test statistic about negative 1.03. For the p-value, I'll make that a positive 1.03. And it's at 35 degrees of freedom. Paste times 2. And the p-value is about 0.31. So that would be fail to reject. There's no evidence that the two groups have different means.